Hello everyone, this is Unit 9, Lesson 5 homework, and we are going to work with the quadratic formula in this homework to solve for the roots of any quadratic. Remember, the quadratic formula always works, so it's something that you should learn definitely, and also check your answers with the calculator. Alright, so we're going to start with number 1. We'll do this one together, and then we'll just go ahead and do 2, 3, 4, and 5 on our own, and we'll go over the answers. So, taking a look at this x squared plus 8x plus 5 equals 0, I would not use the quadratic formula for this. I would, if this wasn't an open-ended question on quadratic formula, I would not use it. I would just put this directly into the calculator, figure out the roots, and that's about it. But since we are learning the quadratic formula, and since we're studying the quadratic formula, we have to put down the a, b, and c. This is the first thing that you do. Remember, the a is always the number before the x squared, so that is 1. The b is always the number that is coefficient that is before the x, so that is your 8. And then the c is always the number that is by itself without any variable, that is your c. So we have a, b, and c. Now we are going to use the quadratic formula, which is right here, and you have to commit to memory. Remember, it's negative b plus or minus square root b squared minus 4ac divided by 2a. And just if you use it enough, you will start to learn it. All right, so it's negative b. So this is 8, negative 8, right? Because we're going to change that. Then it's plus or minus, and then the square root of b squared, which is 8 squared, minus 4 times a, which is 1, and you put that in parentheses, and then times c, which is 5. And I'm going to divide that all by 2 times a, which is 2 times 1, just like this. So we have negative 8 plus or minus square root 8 squared, because we have the, let me just bring this over, b squared, which was 8 squared, minus 4 times a, which is 1, times 5, which is c. And I put that directly into the calculator, this part right here underneath the square root, and I got 44. So you could tell in my calculator when I did bring it up, it's 8 squared minus 4 times 1 times 5 is 44. The square root of 44, if I put that into the calculator, and this is exactly what you use your calculator for, it becomes 6.633, and it says if necessary round to the nearest hundredth, and I did 6.63 right here. That is the square root of 44. It is negative 8 plus or minus 6.63 divided by 2. So then next, I am going to split those equations up, just like you see here. And we have negative 8 plus 6.63 over 2, and negative 8 minus 6.63 over 2. Putting that into the calculator, you get x equals negative 1.37 over 2. And then negative 14.63 over 2. The last thing is to get the answers. And you have x equals negative 0.69. That's negative 1.37 divided by 2. And negative 14.63 divided by 2 is negative 7.32. And those are the roots of this quadratic. All right. Again, you could go ahead and use your calculator. Just put this in. All right. So if you just bring up the calculator and you go ahead and you put that in, it's x squared plus 8x. That's why it's so difficult to do this. You know, just kind of factoring. It's ridiculous. Right here is the negative 6. Right here is the negative 0.69, and negative 7.32 would be right about here. Now, obviously, you can't see that's not. You don't know, so you have to just go ahead and do that second trace and do the 0 value, and then go left bound, right bound, left bound, right bound, and then you can get exactly where that is. But as long as it's kind of close, your answers are correct. All right. If I did that left bound, right bound, and figured it out, it would be negative 0.69, or very, very close, where you could round it to the nearest hundredth, and it would come out to be that. All right. So definitely use the calculator to check your answers. So here we go. All right, so number 2. Again, this is 1, this is negative 3, and this is negative 154. Just remember, when you're putting down the list of A, B, and C, just remember to put the negatives with it. If it's a negative 3, if the negatives before that A, negative 3, it is a negative 3. This is a negative 154. All right, so go ahead, see if you could put all of those numbers in to the quadratic formula. Just substitute them in and see if you can get your answer. Go ahead, press pause now. So we have negative. Just remember that when it says negative b and it's a negative already, it becomes a positive. So I put 2 negatives. I put negative from the formula, right? And then it's a negative 3 because b is negative 3. Plus or minus square root negative 3, which is b squared, right? Put that in parentheses, make sure. Minus 4 times 1, which is a, times negative 154, which is c. 2 times a, which is 2 times 1. All right, so I am going to take the calculator, and hopefully you did this already. Clear this out and put in negative 3 inside the parentheses squared minus 4 times 1 times negative 154. And let's see what that comes out to be. That is 625. And I know that that is a perfect square. All right. So, right there. And just to make sure it's a perfect square, 625, square root of 625 should be 25. And it is. All right. And 2 times 1 as your denominator is 2, obviously. So we have 3 plus 25. We're going to split them up. And we have 3 plus 25 over 2. And then 3 minus 25 over 2. So we have 28. 3 plus 25 is 28 divided by 2. So it is, one of the roots is 14. And one of the roots is negative 11. So we have 28 divided by 2 is 14. Negative 22 divided by 2 is negative 11. That is it. Going on to number 3. See if you can do this. Again, it's the same type of question. Go ahead, put A, B, and C down and try this problem. We'll come back with the answers after this. Press pause now. Alright, so we have A is 1, B is 13, C is 30. I substituted in negative B would be negative 13 now, plus or minus square root 13 squared, which is B squared, minus 4 times A, which is 1, 4 times 1 times C, which is C is 30. So all of this I put into the calculator, 13 squared minus 4 times 1 times 30, and that, by the way, just to remind you, that's the discriminant. So it's 49. So if it's greater than 0, it is going to have 2 solutions. If it is 0, if it's equal to 0, has 1 solution. Less than 0, which is a negative number underneath the square root, you can't do that. That means no solution. So negative 13 plus or minus square root of 49, this comes out to be the square root of 49, and that is a perfect square, which is 7. So negative 13 plus or minus 7 divided by 2. I split them up over here, as you can see on the right hand side, is negative 13 plus 7 divided by 2. That came out to negative 6 divided by 2, and negative 6 divided by 2 is negative 3. That's one of the roots. And then you have negative 13 minus 7, which is negative 20. Negative 20 divided by 2 is negative 10. That's the other root. And that's it for that problem. Alright, so here's one problem that you are going to have to work on just a little bit right here. This negative 6 has to go over to the other side and then just rewrite it. And then put the A, B, and C down. Use the quadratic formula like you're used to doing, and that's it. And we'll come back with the answers and review it. Press pause now. Just wanted to make sure that you were set up with this problem. Remember, it has to be in standard form of a quadratic, which is x squared plus bx plus c, and that is not this. So you have 4x squared minus 3x equals negative 6. You add 6 on both sides, and you get this. This is the standard form of a quadratic. So the a ends up being 4. The b is negative 3, and now the c is a positive 6, not a negative 6. There's one of the mistakes that could be made. Go ahead, see if you can do the rest of the problem. Use the quadratic formula that we've been studying. Press pause now. Alright, not much work for this one, but you can go ahead and start substituting in. We have negative 3 as the b, so when you substitute in, remember it has to be a negative b. So a negative and a negative of a negative is positive, which is double negative, makes positive, which is 3. Plus or minus negative 3 squared, which is b squared, minus 4 times a is 4, and 4 times 6, which is c, and c is 6, positive 6. So now what happens, 2 times a in the denominator, which is 8. So we have this. I put exactly this into the calculator, and I'll just bring it up right here. So we have negative 3 in parentheses squared minus 4 times 4, which is your a, times 6, which is your c. And if you press enter right there, you get negative 87. Let me move this. Move my face over. Negative 87, right? If you try to square root negative 87, you should know already what happens, but I just want to review with you. It gives you an error, and it says non-real answers. That is saying that you can't take the square root of a negative number. So That's what you have to put down. Remember, there is no solution. There is no square root of a negative number. So I put a couple of things down just to remind you. Can't take the square root of a negative number. There are no solutions for this quadratic. No real solution at all. Means that this parabola will not intersect the x-axis. Taking a look at this and just checking on the calculator. I have 4x squared minus 3x plus 6. Input it into the calculator. I press graph, and yes, see, look where the parabola is on that graphing calculator, and it is not crossing the x-axis. Easy way to tell right now is that this would have no solution is using the discriminant. Right underneath the radical, underneath that square root, is negative 3 squared minus 4 times 6. And that is a negative 87. As soon as it's less than 0, guess what? That is not something that could be done, the square root of a negative, and that means right there you should know that you will have no solution. And that's it. All right. So the function h of t equals negative 16t squared plus 256 represents the height h in feet of an object from the ground at t seconds after it's dropped. A realistic domain for this function is, just remember what the domain is though. Domain is that the x, are those the x values, or are they the y values? Remember the domain, a realistic domain is the x values, the range is the y. So we're looking for a realistic domain, talking about the input, right? So the first thing I am going to do is take the calculator. Of course, I am going to graph this equation that they give me and see what I see. All right, see what I notice. So I have negative 16x squared plus 256. So go ahead, put that into the graphing calculator. I'm going to press graph. And I don't know. All right, so we have, let me just say, okay, so I'm going to press second function table just to see what is going on here. All right, as far as basically all those numbers. So I'm looking at this right here. I'm looking at the x values, and as soon as the x value is negative, is that a realistic domain for the height? No. To make sense of this, I'm just going to look at it again. I graphed it. You know I used the graphing calculator. All right. It represents the height h of t in feet of an object from the ground at t seconds after it is dropped. All right. T seconds after it's dropped. So just take a look at my calculator. I'm going to take these windows. I'm going to take the window and I'm going to put the y max, which is the height that I'm going to see to 300 on the y-axis. So I'm going to extend that y-axis all the way up so I can see the top of that parabola. And now I could see the top of the parabola. So I'm dropping this all the way down to here, which is the ground level. All right, what is a realistic domain from here to here? And the domain, that's the axis. That's the x value. All right, so look, just take a look at this domain. And is it negative 4? Is it t is greater than or equal to negative 4? T is less than or equal to 4? Or is it just from 0 to 4? Is it from 0 to 256? That's not the domain. Is it all real numbers? That's not the domain, right? Domain cannot be all real numbers. And all real numbers includes all negatives and positives, so it cannot be that. So the only one that it looks like, if you could just take a look at it, the domain from here to here, right there, of the ball being dropped is number 2. And that's the reason why I wanted to show you that as far as like how important to extending that window is on the calculator. It makes sense. It kind of puts a visual in at the time for you to understand what is happening, and that's it. So that was number 5. Hopefully this video helped you, and see you next time.